Number 8, taken from the A-level PastPaper C2 January 2013. Topic is differentiation. The curve C has equation of the sort where x is not 0. Use calculus to show that the curve has a turning point P when x equals to square root 2. So you need to reach a place where this y, or this equation of the curve, has the turning point which is P and its x is square root 2. So we first have to derive. So take the derivative of y, and then step 2 is to replace the derivative to be 0. Then solve for x and find that this x is going to be equal to square root 2. So first we have to rearrange this y and write it in the form that you can easily derive. So you start with y equals to 6 minus 3x minus 4, and you take the x to the numerator by changing its sign of its exponent, so it's minus 3. Then you start deriving the constant. Derive it is 0 when you derive the constant. Then you multiply, in this case here, 1 times minus 3, then you subtract 1, so the x is not there anymore. Minus 3 times minus 4 is plus 12, and subtract 1 is going to be minus 4. So y prime is this. You replace it equal to 0 and you solve for x in this one here. Solving for x, so all of this is algebra. So I told you before, whenever you have a fraction and this fraction is equal to 0, therefore the numerator only is equal to 0. So you place the numerator equal to 0 and then you solve for x. And here you can use your calculator and you can find x is equal to square root 2 if your calculator gives you square root answers. Or else you have to derive it in this manner. X to the 4 is 4, so x squared to the 2 is equal to 2 to the 2. Therefore x squared is equal to 2 because you take away these 2's. X squared equals to 2, therefore x is equal to plus or minus square root 2. But since we know that we have one turning point, therefore we take the positive, which is square root 2, which is the one that they are asking in the question. Part B, find the x coordinate of the other turning point Q on the curve. Therefore now we are going to use the minus square root 2 that it already showed here. So Q has a minus square root 2 for its x. They only wanted us to find the x coordinate, therefore we only write square root 2 for x of Q, and then y Q. They want us to find the second derivative in part C, so you take the value, or you take the, I need to clean this up so that I can work properly. So you take y double prime, or you take y prime, this is the value of y prime, and then you take the second, you derive it again. When you derive it again, you're going to have, this is a constant, so its derivative is 0. Then you multiply 12 times minus 4 and you subtract 1. It's minus 5, which is equal to minus 48 over x to the 5. Hence, or otherwise, state with justification the nature of each of these turning points P and Q. So since we already found the second derivative, we take the value for x of P, replace it here and check if it's negative or positive, and accordingly we decide the nature of the turning point. So y double prime of P is minus 48 over square root 2 to the 5. The answer is negative. So when the answer is negative, therefore P represents a maximum point. You take the value for x of Q and you replace it also in the second derivative, and then you are going to see that using algebra it's greater than, so it's positive, greater than 0, therefore the turning point Q is a minimum point. These are rules there that you should memorize in order for you to do, or to, so that you can solve these kinds of questions.